Okay, so that is the aniline. Aniline shows their fit 280 nanometer. So because it's having a non-bonded electron means n electron, so n to pi star transition takes place. So you know the n to pi star transition requires the minimum amount of energy for that excitation. So at that time, this can show the types of peak on higher wavelength. Okay, due to the n to pi star transition, because the heteroatom is present, the type of functional group is present to the double bond. Okay, absorption and intensity shift. So bathochromic shift, that is the red shift. Hypochromic shift, that is the blue shift. Okay, this is the two types of shifts are there. So accordingly, first we see the shift. In the absorption maxima of a compound shift to longer wavelength, it is known as the bathochromic shift or red. Maximum wavelength ला जेव्हा ते shift होतात त्याला bathochromic shift असे म्हणतात. The effect is due to the presence of oxochrome or by the change of solvent. This effect is generally shows by the presence of oxochrome. If there is any oxochrome present, means any functional group is present, n to pi star showing the present group is present. So that can change that bathochromic shift. An oxochrome group like OH, OCS3 cause the absorption of compound at a longer wavelength, means lesser at the lesser the energy. Okay. Bathochromic shift in an aniline medium, paranitrophenol shows the red shift because the negatively charged oxygen delocalizes the more effectively than the unshared pair of electrons. Okay, here when we observe, this is the two conjugated systems are there, means this is, we can say it is the resonance structure. Yes, so जेव्हा proton abstract झाल्यानंतर after paranitrophenol, after deprotonation, proton absorption takes place here. So we get this types of compound. So its wavelength is 265 nanometers because they strongly donating the giving the electrons. Okay, that's why their absorption takes place at higher wavelength because negatively charged oxygen delocalized in the conjugation. Okay, this negative charge rapidly delocalized. More the delocalization, higher the absorption of at the higher wavelength the absorption takes place. Okay, that's why that is the, you can say, bathochromic shift. Normal is standard 255, but when it base एखादा absorb केला, a proton absorb झाला, at that time the shift is increases. Okay, that is the bathochromic shift. त्याच्या standard shift पेक्षा काय झाली, shift थोडीशी extend झाली, पुढे झाली, add झाली extra. Okay, hyperchromic shift, blue shift, when the absorption maxima of a compound shift to the shorter wavelength, it is known as a hyperchromic shift or a blue shift. Okay, the effect is due to the presence of a group cause the removal of conjugation. If any conjugation removal of group is present in the near or by the change of solvent किंवा conjugate removal group is present in that sample, so it can show the hypochromic shift, means blue shift. Okay, so aniline shows the blue shift in an acidic medium. If it is the acidic medium मध्ये आपण aniline चे wavelength बघितले, it loses the conjugation because proton abstraction takes place, there will not be deal with this conjugation. इथं काय it's lone pairs conjugation करणार आहे, n to pi star transition shows करणार आहे. So it shows the spectra at the higher wavelength 280 nanometer. But here when the protonation is takes place, no lone pair is present for the conjugation. So it shows the peak lambda max at 265 nanometers. That is the lambda max maximum. Okay, this is the hyperchromic shift. When the absorption intensity of a compound is increased, it is known as the hyper. Due to any effect, the shift is increases. So we can say it is the hypochromic effect. If the oxochrome introduced to a compound, the intensity of absorption increases. This is the period in Lambda max is 257 nanometer. When any substituents attach here, so it increases their wavelength, absorption wavelength. Okay, so 2-methyl pyridine shows 260 nanometer. Means some of the differences happen. Why? So that effect is hyperchromic effect. Due to this, the absorption intensity of that compound is increases. Okay, so we can say it is the hyperchromic shift. Hypochromic. Hyper means extra. Hypo means it's reduced form. Same hypo, that is the hypo. When the absorption intensity of compound is decreased, so it's known as the hypochromic shift. It is the naphthalene. It is the 19002. It is the 2-methyl naphthalene. 1025. Very much changes happens here. Okay. Shift and effect, that is the hyperchromic shift. Okay. Red shift means hypsochromic. Okay. It extend their maxima. They decrease the maxima. Blue shift. Okay. So what is the applications of UV visible spectroscopy? The application is qualitative and quantitative analysis. It is used to characterizations of aromatic compounds and conjugated olefins. To characterize them, to identify, to know that the functionality or the conjugation is present in there, so it can identify by these types of spectroscopy. It can be used to find out the molar concentration of the solute under the study. Okay. So determinations of impurities. It is one of the important method to detect the impurities in organic solvent. If there is any impurity, so we can identify by these types of spectroscopy. Detection of isomers are possible. If there is cis isomers or trans isomers are there, so it can be detection takes place because shift wavelength, different wavelength la shift absorb. Okay, cis and trans isomers. So trans and cis a different wavelength la absorb honar, so it can be identified that the shift trans isomers are possible still. So those shares the two different peaks. Okay, so determination of molecular weight using the Beer's law. Okay, hope you understand this term. This is ultraviolet spectroscopy. Okay, so we will see some of the examples from the ultraviolet spectroscopy. Okay, I have posted your attendance. You should go and view your attendance. Have you given your attendance?
Yes, sir.
Okay. So that is the Woodward, some of the rules to homonucleotides and dinophiles are there. Okay, dines and enones are there. Yes. Hello.